Welcome to another GCBASIC video. Please like, subscribe, comment, etc. I need your support to keep the videos coming. Okay, so as I said, like, subscribe. AVR Info is a new application for GCBASIC. We've had something similar to AVR Info with our PIC chips for a long time, and this is just a new application to support the AVR DX chipset, but it actually works across all the AVRs. So let's just have a quick look at a really simple program, and that's not what we're here for, but this is a simple program to program a Mega 4809 that just flash an LED and wait 10 milliseconds. It's not important what this says really because I'm going to press function key F5 and it will then compile that up and then it will actually do the flashing. I'm not going to bother showing you that, it's already done it. It takes less than 1.8 seconds to compile and assemble that, and then milliseconds to actually program it, and it's doing it. But let's assume that you wanted to know something more about the Mega 4809, and that's where AVR Info comes in. So in the IDE, press function key F4 and type in AVR, and it will be the first option that comes up. AVR Dude is also there, but AVR Info is the one that we're interested in. It will open up a new application. Let's zoom in on that. I'll bring it across into the screen so that you can see it fully. Is that a good shot? Hey, that's not too bad, actual fact. Let's just shuffle that up a tad. You can see the whole thing now, and that's all that matters. I'll just get rid of the background so we can just focus our eyes on the application. There we go. And what we've got here, it happens to be showing a whole list of AVR chips here. There's loads of them, and I will just type in the one I want, Mega 4809, and you can select this by typing it at the bottom like a search routine or in the drop down at the top. And it essentially shows you in this little diagram here what we're looking at. We're looking at a Mega 4809, the DFP pack, and the DFP pack is part of the Microchip installation that we imported. We've sucked that information into GCBASIC, and it says that it's a DFP pack, and it's a chip family 140, and that's a number that we use to signify this type of chip within GCBASIC. It has 256 bytes of RAM, 2,457, 2,000, and that's 24,576 words. I guess that's words. And in RAM, it's got 61664. So what's the data? The data is clearly the EEPROM. And if you want the data sheet, you can click on here to be taken to the data sheet. Another way of doing that is over here in the device dashboard. So if you click on that, it will automatically open up in the background for you in a browser. There you go, look. There's the data sheet sitting there for that particular model. So you don't have to go hunting around to figure it out on the Microchip website. You can do it directly from AVR Info. Inside of here, you can also open up the preference editor. That's a tool that's within GCBASIC, and that allows you to select your programmer, your compiler, or your assembler. I'm currently using AVR ASM. If I wanted to use GCASM, I would simply select that. You can also go direct to the IDE, and it will show the DAT file, and the DAT file is part of GCBASIC. It's the descriptor that this actual application is reading, and you can open that up inside of the IDE. AVR Dude is also accessible. You've got some other device dashes in here in terms of the web page of the product and other documentation. So really quite simple. So what we've got is an overview here of this chip, and if I select an older chip, it might not have all the data there because we are now collecting a lot more information about the chips to make it a richer environment, and we'll add more to this as we go through. For instance, this is its legacy AVR group and chip family 120 for this particular random chip that I've just selected. Again, if you take something like a Mega, is it 25? That's the 2560, huge chip. It's got an EEPROM of 4K, program of 131K, and RAM of nearly 8K, over 8K. That's a big old chip, that is, isn't it? But we'll go back to our 4809. Here's my 4809 that I was working with, and if I wanted to know the parameters that describe the chip to GCBASIC, they're in the chip tab. Just select the chip tab, and it will list in here, and it will tell you what the frequencies are for this chip under things like int oscillator, and it says that that's exposed inside, can be exposed inside your program. And it sort of says in here that most of these constants here are available within your program as the prefix of chip. So if you wanted to know how many ADCs there were, you could say chip ADC. The maximum operating frequency is revealed. And there's many other parameters in here that GCBASIC exposes, and they're used throughout libraries and can be used within your program to understand the parameters of this particular chip. There's your interrupts. Let's just look at the interrupts. Series of interrupts. All the interrupt masks are in here. So this is what we call it within GCBASIC. This is the actual name you might find documented in the datasheet. It's on interrupt 2. And these are the 2-bit. This is the enable bit because it's under the enable. There's an enable bit. That's how it's enabled. And then there is an event bit. And that event bit will have to be cleared or reset upon exit. Remember, GCBASIC does a lot of this work for you, but it's worthy of note. So you've got a really good understanding of all the interrupts that are available. Registers. These are the registers themselves, and these are pulled in directly from the DFP file or the include file as it used to be called. And these are the registers, their addresses in decimal and in hexadecimal. So you can get a good handle in here, and you can sort for something like, give me the address of port F _ out. Did it find it? Might be sensitive. Port F. There isn't a port F on this chip. There is. Oh, there it is. Just found it. I wasn't searching correctly. _dir, and it will list out all the ones with the correct match. Just a search. AVR masks, they're useful in your program. And these are all the masks that you can use within your program. So you can use pin 0.bit mask, _bit mask, and all the other bit masks are in here so that you can actually use those within your program. And these are also pulled in from the DAT file so that you can use them. And finally, bits. In here, you've got all the bits that are defined by the system. So what you've got is a very quick way of searching through. You can list them all, you can pull them out and do things with them in your program as you see fit. And so in here, you can see that you've got great access to most of the parameters of a chip. And it works for the older chips too. If I go up to these are all the new ones. Is that an old chip? That's a legacy AVR. You get a lot less data in the chip data because we didn't suck in a lot of data in the older days. There are no masks available. Registers obviously is there. The bits are there, and the interrupts are there. But AVR masks just don't exist within the legacy AVR set. If we need them, we can pull them in. Let us know. But at the moment, all we've got is this great diagram, and you can do your searches. So what I wanted to show to you is a quick flyby of AVRInfo. It's a great new tool. Probably we can make it better for you. Just let us know what you want to do. But please let us know and enjoy. Thank you. Subscribe and like.